Alright, so this is day one review for your quarter exam. I'll go over the first two sheets that were handed out in class. So you guys know the deal. You can pause, rewind, fast forward, whatever you need to do to prepare yourself for the quarter exam. Alright, so for number one, we have the same bases. So what we can do here is we can add your exponents. So in this case, this is going to look like 9, 1 over 3, plus 1 over 6. I'm going to change the base or change the denominator here, so times 2 times 2. What we have here is 9 to the 2 over 6 plus 1 over 6. That would turn out to be 9 to the 3 over 6, which is also 9 over 1, 9 to the power of 1 over 2. Remember, you can change exponents into radicals. So this would be square root of 9 with the power of 1. Square root of 9 would end up being 3. Okay, so final answer is 3. We have here, again, we have the same base. So we've got the same base. This is where dividing here, so we can subtract the exponents. So 4 to the 3 over 4 power minus 9 over 4. That would turn out to be 4 to the negative 6 over 4. Okay, we can simplify this a little bit. 4 to the negative 3 over 2. What can we do with negative exponents? Well, we can flip them. So this would turn out to be 1 over 4 to the 3 over 2 power. Once we flip them, it becomes positive. We can change exponent form into radical form. So my base is 4. My power is 3. My root is 2. So root is 2. My power is 3. Square root of 4 is 2. 2 to the third power is 8. Well, this would turn out to be 1 over 8. So 1 over 8 would be your final answer. 3. In number 3, yes, we have different bases. Okay, so actually we can end up changing the base here. So that's one way to do it, but we also have the same exponent. Now, if you didn't recognize that they have the same exponent, what you could do is, well, I can make this a power or base of 2. So 2 to the third power is the same thing as 8. 1/2. Again, base of 2 to the 1/2 power. 3 times 1/2 is 3 over 2. So 2 to the 3/2 power times 2 to the 1/2 power. Well, now I've got the same base. I can add my exponents. 3 over 2 plus 1 over 2 is 4 over 2. 4 over 2 is 2. So 2 to the second power is equal to 4. So this should be 4. Alright, number 4. Number 4, we have the same exponents. Again, we can, there's different ways to doing this. We can change the base. Well, actually, that won't really help us out. But this ends up having the same exponent. So we can say 12 over 6 to the third power. Right? 12 over 6 is, of course, 2. Well, 2 to the third power would end up being 8. Okay, so final answer here is 8. Number 5, we have this whole expression taken to the 0 power, so that would just end up being 1. Anything taken to the 0 power is 1, so that's an easy one. Alright, number 6, we're looking for the same base. These have the same base, this one doesn't, so there's something we can do about 25. 25 we can change into 5 to the second power. Of course, we can't forget about this, so 1 over 4 on the outside, and then 5 to the 1 over 3, 5 to the 1 over 6 power. 2, this is power to a power, so 2 times 1 over 4 is 2 over 4. 2 over 4 is 1/2, so 5 1/2 times 5 1/3 times 5 to the 1 over 6 power. I have the same base. What I can do is add my exponents. 1 over 2 plus 1 over 6 plus 1 over 1 over 3 plus 1 over 6 would end up being 1. So now I have 5 to the first power. That would just be 5 as my final answer. Okay, you'd have to change your denominators here, at least for this and this, to make it look like 6. All right, number 7. Number 7, we have this expression. We have 3 to the 0. We can change 3 to the 0 into 1. But then again, we don't really need that 1 there since it's not going to really affect our answer. So we have here is 3 to the 1/3 power, 9 to the 1/3 power over 27 to the 2/3 power. What we can end up doing, again, take this piece by piece to the top first. 1 over 3, 1 over 3, we have the same exponent. So what we can do is multiply our bases. So 3 times 9 is 27. So that would end up being 27 to the 1 over 3 power. Of course, we have our denominator, which is 27 to the 2/3 power. Well, now we have the same base, 27 and 27. What we can do is subtract our exponents. So 27, 1 minus 3 minus 2 over 3. That would end up being 27 to the negative 1 over 3. Okay. Negative exponents means we can flip that fraction. So this would turn out to be 1. And how about we change this into a radical form? So power and root. So this is the cube root of 27. Of course, cube root of 27 would be 3. 1 over 3 would be our final answer. All right, number 8. Number 8, we have the same exponents, which is awesome because, again, we can kind of do something similar to like the last problem. 9 times 3 taken to the power of 1 over 3 over 6. Of course, 9 times 3 is 27. Okay. Now, there's not much we can do here, but we can simplify the top first. So changing exponent form into radical form, that would turn out to be the base of 27. Power is 1. Root is 3. Okay, the cube root of 27 is 3. 3 over 6 would turn out to be just 1/2. So our final answer here is 1/2. All right, so now we're at exponential equations. Again, the key with exponential equations is to have the same base on each side. Okay, so we're probably looking for a base of 4 or possibly 2 if you want, but 4 seems to work out. So what we can do here is, again, 4 to the x. Well, how can we change 1 over 16 to have the base of 4? Well, we can say 1 over 4 to the second. Okay, we're kind of getting there. How about we say 4 to the negative 2, right? All these are the exact same thing, except now I have a base of 4 now. So 4 to the negative 2. Well, same base. That means I can set these equal to each other. So x is equal to negative 2. All right. Again, we want the same base. It's hard to see at first, but this is 1 we can change into 5 to the 0 power. Now, well, guess what? Now we have this base of 5 here, and we have the base of 5 here. So we end up setting our exponents equal to each other. Okay, this will end up factoring as x minus 1, x plus 1. Set these equal to 0. So x is equal to 1 and negative 1. That would be our final answer. All right, number 3. Well, we have the first thing you should do before you start this process. Again, I'm probably looking for a base of 3. First thing you should do is add 27x to the other side, because again, we want to compare the bases. So 9, 2x plus 1, and then 27 to the x power. Now we can start breaking this down into most likely a base of 3. So 3 squared is the same thing as 9, and then 3 cubed is the same thing as 27. Okay. What we can end up doing here is power to power. 2 times 2x plus 1 is 4x plus 2. Okay, and 3 to the power of x is just 3x. Alright, same base. We can set these two equal to each other. So 4x plus 2 is equal to 3x, minus 3x, and then minus 2. Okay, that would end up being x is equal to negative 2. Alright, number 4. Number 4, we have 3 to the 2x power is equal to 27. Again, I'm probably looking for a base of 3. So 3 to the 2x, that has a base of 3 already. 3 to the third power, I have the same bases now. I can set these equal to each other. So 2x is equal to 3, divide by 2, x is equal to 3 over 2. Okay, number 5. Again, I'm looking for probably a base of 2. So 2 to the second power is the same thing as 4. And then 2 to the fifth power is the same thing as 32. Okay. Again, I have a base of 2, which is a really good sign. Power to a power, that would mean 2 to the power of 2x is equal to 2 to the power of 5. Same base, set these equal to each other. 2x is equal to 5, divide by 2, x is equal to 5 over 2. So that would be your final answer. Alright, number 6. For radicals, again, I'm probably looking for a base of 2. But for radicals, you want to always change those into exponent form, especially when it helps you out here. 2, or square root of 2, is the same thing as 2 to the 1/2 power. Again, this and this are the same exact thing. Okay, one's in radical form, one's in exponent form. Of course, I can't forget about that 3x that's hanging out. And then 1 over 8 I can change into 1 over 2 to the third power, right? Let's do power to a power here. 1/2 times 3x, that's 2 to the 3 over 2x power. And then, again, I'm looking for a base of 2. Let's change this to 2 to the negative 3. Again, this, and this all mean the same thing, okay? Alright, same base. I can set these equal to each other, so 3 over 2x is equal to negative 3, okay? I can multiply by 2 over 3 just to cancel those out. And then do the same thing here, 2 over 3. Okay, those 3's will end up canceling out, so x should be equal to negative 2. 7. Again, probably base of 3. 1 over 9 is going to turn out to be, you can say 1 over 3 over 2. Of course, we can change that to 3 to the negative 2 power. So again, 3 to the negative 2 power is the same thing as 1 over 9. Can't forget about the x plus 2 that was, again, that's hanging out to that 1 over 9 is equal to 3. Of course, 3 to the first power is the same thing as 3. Alright, power to a power. So 3 to the negative 2x plus 2. I'm going to have to multiply here, so negative 2x minus 4 is equal to 3. Same base, set these equal to each other. I've got negative 2x minus 4 is equal to 1. Add by 4. Negative 2x is equal to 5. That means x is equal to negative 5 over 2. Alright, number 8. Number 8, we have a bit of a tough one. It's actually not too tough. What we can end up doing here, again, we probably won't have the same base here. Like 4 and 5, there's nothing we can come up to have the same base. So that's not going to help us out. What we can do is maybe we can change the exponents, right? Maybe we can have 2x here, right? So basically what I'm trying to say is we can change 2 squared into, 4 into 2 squared. And of course have 5 to the 2x power there. Well, 2 to the power of x is 2x. Okay, so now we have the same exponent. We can multiply the bases. So that would be 10 to the 2x power is equal to 10. Same base. I can set these equal to each other. 2x is equal to 1. That means x is equal to 1/2. Alright, number 9. Again, we want to be basically comparing bases. We can only compare them if one of them is on the other side. So move 1 to the other side. Okay, and then think about it. Is there really a base we can come up with between 7 and 1? Okay, we can if we end up having the equivalence of 1. Well, this and this is equivalent to 1, so 7 to the 0 power is equivalent to 1. What we can end up doing now is setting these equal to each other, so x squared minus 4 is equal to 0. We can break this down even further. X minus 2, x plus 2 is equal to 0. Set both of them equal to 0. That means x is equal to 2 and negative 2. 10. I'm probably looking for a base of 3. Let's change this to a base of 3 by saying 3 to the second power. Well, that will just turn out to be 3 to the 2x power. Radicals can change into exponents by, again, this is my root, the power of 1. So I can say 3 to the 1/2 power. But of course I have that exponent hanging out on the outside as well. Let's go ahead and do power to power. So this is going to turn out to be 3 to the 1/2 x plus 1 power. And this is of course the same base, same base. We can set these equal to each other. 2x is equal to 1/2 x plus 1 minus 1/2 x minus 1/2 x. That's going to turn out to be 1.5x is equal to 1. Divide by, so 1.5x is equal to 1. Divide by 1.5. Divide by 1.5. Okay. 3 over 2. Alright, number 11. Number 11 we have 4 to the x power divided by 2 to the power of x minus 1 with 8 to the 2 minus x power on the other side. Again, we're probably looking for a base of 2 here. So let's change 4 into 2 to the second power. So this is going to turn out to be 2 to the 2x power. Let's keep this. Let's change 8 into 2 to the third power. Okay. And then let's kind of clean this up a little bit. So 2 to the 2x power over 2 to the x minus 1. Let's do power to a power here. So 2 to the 6 minus x power. Alright? Again, I'm dividing here and I have the same bases. So I can subtract these exponents. So 2x minus x. And let's actually take this slow because I do want to show this step. Okay, don't make this common mistake. Okay, there's a negative. You're subtracting this whole binomial expression, so negative and negative. Okay, 2x minus x is x. Minus minus, that will turn out to be x plus 1. Let's turn this up here. So 2, that would be x plus 1 is equal to 2 to the 6 minus x power. Same base, I can set these equal to each other. X plus 1 is equal to 6 minus x. Plus x, that would be 2x. Let's do minus 1, minus 1. So 2x is equal to 5. Divide by 2, divide by 2. X should be equal to 5 over 2. Okay. Again, move this over since we want to compare bases. So 4x squared minus 6 is equal to 16x plus 1. Let's change, we can change this to 4 squared because that's the same thing as 16. If we change it to 4 squared, again, we can do power to power now. So that would turn out to be 2x plus 1, or 2x plus 2. Okay, same base. I can set these equal to each other. X squared minus 6 is equal to x plus 2. Minus 2x, again, push everything to one side. Minus 2x, minus 2, x squared minus 2x minus 8 is equal to 0. Okay, let's end up factoring this. this would factor into x minus 4 and x plus 2 is equal to 0. So x is equal to 4 and x is equal to negative 2 would be your solutions. Alright, number 13a. We're using substitution here. So what we're trying to say is y is equal to 3x power. That's a way we can solve for this equation to make it easier on yourself. Otherwise, it's a complicated problem if we're not using substitution. So whenever we see 3 to the power of x, we're going to replace it with y, and then make sure at the end you replace y or solve for x using the y that you just got. So a couple things. Again, 3 to the x power, we'll change that to y, but I see 3 to the negative x power. Well, I can still change this to y by saying, well, how about I do this? 3 to the x power and then to the negative 1. They still mean the same thing, right? So this, right, and this mean the same thing because x times negative 1 is still negative x, right? But now I can actually replace this with y. So I'm going to replace what I need to replace with y. So y is equal to 4 minus 3. Replace this with y to the negative 1 power. Let's clean this up a little bit. So y is equal to 4 minus 3. We can change this to 1 over y because our negative 1 dictates that we can flip this. Negative 3 times 1 over y is negative 3 over y. Okay. Now, instead of adding 3 over y and 3 over y here, probably the best thing to do is actually multiply everything by y so we can just cancel this y out. Because probably the best thing, easiest thing to do is not to deal with this fraction. So if we multiply by y to everything, so y times this, and y times this, because again, we want to cancel that y out, that would turn out to be y squared is equal to 4y, and then y and y, they will cancel out, so minus 3. Okay, push everything to one side, so minus 4y, and then plus 3. So y squared minus 4y plus 3 is equal to 0. Okay, we can factor this by saying y minus 3 and y minus 1 is equal to 0. Well, we have y is equal to 3 and y is equal to 1. Okay. Now it might seem like we can basically end the problem here, but again, we want to find the values of x. We just found the values of y. Okay, so we have a couple more steps left to find the values of x. Okay. Now remember what we substituted for the power of x. So I know 3 to the x power is equal to 3. 3 to the x power is also equal to 1. Okay, so 3 to the x power is equal to 3. And 3 to the x power is also equal to 1. What does this value have to be? Well, x has to be 1 here, so that's one of my answers. What does this value have to be? Well, it has to equal to 0, because 3 to the 0 power is equal to 1. So x should be equal to 0. So 1 and 0 are your final answers. Alright, again, whenever we see 3 to the x power, we replace it with y. It's a lot easier if we end up using substitution here, because it gets complicated if we try to do this freehand. Okay, so again, wherever I see 3 to the x power, I'm going to replace it with y. So one slight problem here. Let's change this into 3 to the x power squared, right? And then let's change this to 3 to the x power times 3 to the second power, because this and this mean the same thing. Again, we have 3 to the x power, we don't have to do anything with that, and then minus 9. Every time we see 3 to the x, we're going to replace with y, so I'm going to replace this with y. I'm going to replace this other thing with y before I do that. Okay, this I can replace with y times 9. 3 to the second power is 9. Okay, and again 3 to the x power I can replace with y. Alright, we need to solve for y and then eventually solve for x. So y squared 9y is equal to y minus 9. Move everything to one side, so minus y plus 9. So minus y and then plus 9. This would turn out to be y squared minus 10y and then plus 9 is equal to 0. Let's end up factoring this. So that would factor as y minus 9 and y minus 1 is equal to 0. That means y is equal to 9 and y is equal to 1. Again, we're not done yet because again we have the values of y, but we need to find the values of x. We know 3 to the x power is equal to 9 and 3 to the x power is also equal to 1. To find what this is, again this has to be x is equal to 2. To find what this is, that means x should be equal to 0. So those are our two answers. Alright, number 14. We've got situation 1 here and situation 2 right there. We have to do these situations separately. Okay, so first situation we have y is equal to 4, x is equal to 3. We're gonna again place the values that we have for x and y. So 3 and 4. So let's do situation 1 first. Situation 1 calls for y being 4 and x being 3. Alright. Again, we're trying to find, we basically just need to simplify this, try to isolate either a or n. In this case, a is probably the easier one to get. So plus 23 plus 23 to 27 is equal to a times 3 to the n power. Let's divide by 3 to the n power, divide by 3 to the n power. And it may not seem like it now, but we can, again, through the practice that we've had before, we can change this base to what? So we can change this to 3 to the third power, because that's the exact same thing as 27. We're dividing here, so that would be 3 minus n. So 3 minus n power is equal to a. We need to find the other value of a possibly to take advantage of this, but all we know right now is a is equal to this, right? So let's go ahead and do situation 2 on the other side. So again, for situation 2, let's rewrite this. I know y is 220 in situation 2. X is 9. Again, I probably need to isolate. So plus 23 plus 23. 243 is equal to a times 9 to the n power. 9 to the n power is what I'm going to divide. 243 and base of 9 have something in common. They have a base of 3 in common. Okay, so 243 I can change into that would be 3 to the 5th power. Okay, I can change 9 into 3 to the 2nd power. So now I have 3 to the 5th power, 3 to the 2n power. I can subtract my exponents because I have the same base and I'm dividing. So 3 to the 5 minus 2n power is equal to a. Well, now I know what the values of a are. I know this is the value of a, this is also the value of a. So what I can actually do is set both of them equal to each other because I know what a here is, I know what a here is, and again they're equal to two different values. So 3 to the 3 minus n power is equal to 3 to the 5 minus 2n power. Same base, which is awesome because I can set these equal to each other. So 3 minus n is equal to 5 minus 2n plus 2n plus 2n. That would be 3 plus n is equal to 5. N would eventually be 2. Okay, and then you can plug this in to find what a is. So if I plug in 2 here, doesn't matter which one. Well, let's do this one because this is easier. 3 minus 2 is 1, so 3 to the first power is 3. That's what a is equal to. So a is equal to 3. Alright, 15. Solve for x and y. Let's do this first situation. So again, let's have the base of 5 here. Since we have the base of 5 here, we can end up adding these exponents then. So 5 to the x power, and then let's change this to 5 squared. Of course, I have 2y right there is equal to 1. 2 times 2y is 4y. So let's change that up. 4y. Base of 5, I can add this and this together. So 5 to the x plus 4y is equal to 1. Again, how can I change this to base of 5? All I can say is 5 to the 0 power. So now I know x plus 4y is equal to 0. That would be my first equation. So that, again, we're going to do simultaneous equations here. Let's move on to this. I'm looking for a base of 3. So 3 to the 5x power. Let's change this to 3 to the 2 power, which is 3 to the 2y power, is equal to 1 over 9. How about we change that to 3 to the negative 2 power? Again, they mean the same thing. I'm just rewriting it so I can have the same base. 3, again, same base. I can add the exponents. So 5x plus 2y is equal to 3 to the negative 2 power. Same base. I can I can set these equal to each other. So 5x plus 2y is equal to negative 2. Okay. I'm gonna run out of space here, but I'll trust you guys on your simultaneous equations. This will be equation number 1. This will be equation number 2. Okay, you can do elimination or substitution, whatever you want to find what x and y are equal to. All right, for 16, I'm calling you to rationalize this. Again, if there's a radical on the bottom, you have to get rid of that. So this is called rationalizing. How you rationalize this or get rid of the radical on the bottom is you basically rewrite this, except there's a plus sign instead of a negative sign, or you just make it the opposite sign. Okay, let's do the top first. So 9 times this and 9 times that. That would be 18 square root of 3 plus 27. Let's do the bottom now. This times this. That would be 4 times 3. Eventually, square root of 3 times square root of 3 is 3. So this would turn out to be 12. So that's the first part. Outside, again, I'm doing FOIL here. So we just did F. Outside would be this times this. That would be plus 6 square root of 3. Inside, again, the exact same thing, except it's minus now. And last, that would be minus 9. Let's clean this up. Well, we can cancel this and this out because they cancel each other out. Now I have 18 square root of 3 plus 27 divided by 12 minus 9, which is 3. I can keep going, right? 18 divided by 3, they will end up simplifying. 27 divided by 3, they also simplify into just 9. Okay, so this would be your final answer. Alright, again, same thing, I need to get rid of this radical on the bottom. So multiply by the exact same thing, except instead of a plus sign, it's going to be a minus sign now. Just do the opposite sign. Okay, again, we're going to FOIL here. We're also going to FOIL here. First, that would be 9 square root of 2 times square root of 2 is 4. Outside, that would be minus 12 square root of 2. Inside, that will also be minus 12 square root of 2. and last would be plus 16. We'll clean that up later. FOIL here, so first and first, that would be actually the same thing. Outside, that would be 12 square root of 2. Inside, that would be plus 12 square root of 2. And last would be minus 16. Let's clean the top part first. So that would be 36. This and this would be minus 24 square root of 2. Yeah, let's actually do this on the bottom. So 36 minus 24 square root of 2 plus 16. 16 plus 36 is 52. Okay, 36 minus 16 is 20, and then these will end up canceling out. Okay, so honestly, it's okay to leave it like this. It's perfectly fine. If you want to simplify, you can simplify, but I'll take this as a final answer. Okay, but you can simplify this a little bit more. So for this last problem, we basically need to prove. Now I think there's a lot of ways to do this, but we need to prove our left side is equal to our right side, or vice versa. Our right side is equal to our left side. So if we can manage a way to where we can make these look the same, we've basically proven that these are equal parts. I would try to do one side and see if that works out, and then not touch the other side, so kind of treat this like an identity. So let's choose our left side. So if we're choosing our left side, again, kind of break down what these actually mean. I can expand this by saying 8x squared to the power of 8 times 8x squared to the power of negative r. Again, they mean this and this mean the same thing. Okay. Let's go ahead and do the same thing here. That would turn, I can just do 1 to the r power and then 2x to the r power. Again, I'm only working on one side. Okay. I have a base of 2 here, so maybe we can change these to bases of 2. So let's change it to 2 to the 3rd power. And let's also change this to the 2 to the 3rd power. Okay. So what we can do here is, again, let's go ahead and do power to power. Because I noticed 2 to the 3rd to the 8th power would end up looking very similar to this. So 2 to the 24th times x to the 16th. And then what we have here is 2 to the negative 3r and x to the negative 2r. Okay, we can end up changing this one as well. Again, there's no fractions in this, so there shouldn't be any fractions on our left side. So if you want to make this equal to each other, what we can say is 1r times 2 to the negative r power times x to the negative r power. The reason I'm doing that is because we're dividing here, and when we're dividing by exponents, we can subtract the exponents in that case. So at this point, we can basically clean this up a little bit. So look for our bases of 2's. Base of 2, base of 2. So that would turn out to be 2 to the 24th power, and then negative 3r, minus r, that would be negative 4r, so minus 4r. So that way, again, we're kind of trending towards our right side. So we're done with this, this, and this. And then x, x, and x. What we can do here is multiply by x to the 16 and then minus 3r. Okay, so that way we basically we've basically proved our left side is equal to our right side in this case. Okay. Alright, so this is day 2 review. This is the second worksheet that we did for your quarter exam. Alright, so converting to log form. Again, you want to do your monkey banana, so first of all, we're going to say log. We'll log base 2. And then p is equal to x. For this one, we have log base 10 of 100 is equal to 2, and log base x of 2 minus k is equal to x. Alright, so converting to exponent form. Again, base of x, that's our monkey. This is our banana, there's our tree. So converting into exponent form, we're going to say x to the 4th power is equal to 3. Again, so base is 2. 2 to the negative 2 power is equal to 1 over 4. Again, base of 2. P plus 1 is equal to 4y. Okay, so again, you have to know from log into exponent and exponent into log. Alright, number 3a. So there's 2 ways to do this. You can, you can do you can put this in exponent form, or you can put this into log form. I'll do it different ways throughout this exercise. Let's do this in exponent form first. So base of 2, it's taken to the negative 3 power. All I'm doing is basically taking this into exponent form. It's equal to 2x plus 1. 1 over 8 is equal to 2x plus 1. This is going to end up being a fraction, so minus 1, let's call that 8 over 8. Okay, so that means 2x is equal to negative 7 over 8. I divide by 2, divide this by, I'm going to multiply by 1 over 2. So negative 7 over 16 would be your final answer. Alright, so 3b. Let's do 3b. Again, I can easily put this in exponent form. Just to show you, I can put this in log form as well. So we have log 9 base 9 of square root of 27. How about we change this to log form, so we can say log base of 9 to 9. Again, this and this are the exact same thing. I can use my power law and state that's to the x power. So finally I have log base 9 square root of 27 is equal to log base 9 to the x power. Log base 9, I can say square root of 27 is equal to 9 to the x power. Square root of 27 Again, we can change this to the same base. How can we possibly do that? We can say 27 to the 1/2 power is equal to 9 to the x power. And then we can keep going. Let's change this to base 3. So 3 to the 3rd power 1/2 is equal to 3 to the 2x power. This would be 3 to the 3/2 power is equal to 3 to the 2x power. I have the same base, set these equal to each other. So 3 over 2 is equal to 2x, divide by 2, divide this by 2. I'm going to have 3 over 2 times 1 over 2 is equal to x. So this should be 3 over 4 is equal to x, your final answer. Alright, 3C. For 3C, again, let's end up doing exponent form, but again, you can easily do put this in log form and solve it through that way. Let's put this in exponent form, so x squared is equal to 6x minus 8. Let's push everything to one side, so x squared minus 6x plus 8 is equal to 0. Let's go ahead and factor x minus 4 and x minus 2 is equal to 0. So x is equal to 4 and x is equal to 2. Okay, both of them end up being defined. This one works and this one works. So both are good. 4a, again, you gotta remember these rules. One of those rules is log base 4 of 4, or anything of the same value, is going to be 1. So again, just to kind of prove it to you, if I'm putting this in exponent form, 4 to the x is equal to 4, of course that x has to be 1. So this value is 1. In order to do this, bring this up front using power law. So 3 times log base 2 of 2. Well, again, same situation, log 2 of 2 is going to be 1. So I have 1 minus 3 now, times 1. Well, that's just 1 minus 3, which is going to end up being negative 2. Alright, 4b. 4b, again, same situation. 3 times 1, again, log x of x is going to turn out to be 1. And then plus 2. You want to do the inside first. So we've gotten the top part, 3 times 1 is going to be 3. 3 plus 2 is going to be 5. This bottom part, we have 4 minus 2 log 5 of base 5 of 1. Again, if you don't know this, we can put this easily in in exponent form. 5 to the x power is equal to 1. Well, what does x have to be? It has to be 0. So this is 2 times 0, right? Well, 5 over 2 minus 0 is 0, so just 4. Squared is going to end up being 25 over 16. So that would be your final answer. 4C. Again, let's do this part first. We're going to end up using power law. We'll bring that up front. Log base 2 of 6 plus 2 log 7 of 7. Log 7 of 7 is going to end up being 1. 6 plus 2 is 8. So we end up having is log base of 2, 8. We can actually keep going. You can say, put this in exponent form, so 2 to the x power is equal to 8. X ends up being 3, but you can do this a long way as well. 2 to the x power is equal to 2 to the 3rd power. So x ends up being 3. 4D. 4D we have log base 5 of 5. Let's quickly change that to 1. Because of course that is 1 and it might make our problem a bit simpler. Right, so again we can do monkey banana here. Log base 2 of, so this is going to turn out to be 2 to the 1 is equal to log base 3 of x. This of course is just 2. Again, we can actually do this one more time. So 3 to the 2nd power, we can still keep doing exponent form. So 3 to the second power is equal to x, right? And of course 9 is equal to x. 5a, there's a couple of ways you could do 5a. You need to clean this up a little bit. So log base 2 of 2, how about we change this to 2 to the 1/2 power, right? They still mean the same thing. Well, I can end up multiplying these because they have the same base. Again, this has a power of 1. 1 plus 1 over 2, well, that would be log base 2. And then 2 to the 1 plus 1 over 2 is 3 over 2. Right, now we can end up using power law, bringing that up front. 3 over 2 times log base 2 of 2. Well, 2 of 2 is just going to be 1. So 1 times 3 over 2 is just 3 over 2. Alright, this is 5b. So for 5b, again, 1 over a cubed. Again, we can possibly change that to log base a. We can say a to the -3. Right, now we can end up using power law, bring that up front. -3 times log base a of a. Well, log a of a is just 1, so 1 times -3 is equal to -3. Alright, 5c. For 5c, again, your best bet is to change these so they might possibly cancel out. Let's change this to log base a and 3 over 2. Let's change this to 2 times log a and then 3 to the 3rd power. What we can end up doing here is doing power law, so we can move that up front. We can also move this up front. So we have 2 times log base a of 3, and then 3 times 2 is 6 log base a of 3. Log base a3, log base a3, they end up canceling out. You end up having 2 over 6. 2 over 6 is 1 over 3. 6a, we're gonna write this as a single log. Okay, so you're gonna have to use your logarithm laws. So again, the key thing is if you end up having the same base, you can end up in this case dividing, or in this case adding. So let's go ahead and divide first, but before we divide, let's put these up front so it's easier to simplify. So log base x of 5 squared would be 25. Again, we're dividing, or so we're subtracting. In this case, we can divide log base x of 6, right? We're also adding, which means we're multiplying log base x over 4. Okay, so this actually should be 8. Sorry about that. 2 to the 3rd power is 8. 5 squared is 25. All right, 25 times 4 would be log base x over 100, and then log base x over 8. We can say log base x over 100 over 8. That would be basically 25 over 4, or 25 over 2. Okay, so this would be your final answer. You can write this as your final answer. 6b, very similar to problem to the last one that we did. Before we start, again, we want to write this as a single logarithm. We're dividing here since we're subtracting. We do want to use power law to our advantage here. Also here, we can use power law. So instead of putting this front, we can put this in the back. Instead of putting this up front, we can put this in the back. So we're taking this to the 4th power. We're also taking this to the 2nd power. So let's simplify here. 8 over 75. Again, we're dividing, so divide by a log. 3 squared is 9. 5 squared is 25. We're also multiplying. Again, we're adding here, so we're multiplying that. 3 to the 4th power is 81, and then 2 to the 4th power is 16. Again, we're dividing by, here, let's rewrite this a little bit. So log base 8 over 75 times 81 over 16, and then divided by 9 over 25. Okay, so whenever that happens, we can multiply if we flip this fraction. So that would be 25 over 9, and we multiply. So once we flip it, we can then multiply. So we're gonna have to clean this up a little bit. All right, so let's say 8 over 16, well, it can change into 1 over 2. 81 over 9, that can change into 9 and 1. 25 over 4, or sorry, 25 over 75, that can change into 1 and 3. So 1 times 9 times 1, that would be log base 9. And then 3 times 2 times 1, that would be 6. So this would be log base 10, and then 3 over 2. All right, 7a. Again, we're going to apply the logarithmic rules that we learned much earlier. So again, we're adding, so that means we can multiply this and this. So that would be log base 3. So again, we're going to FOIL this, and this. That would be x squared minus 4. And then log base 3 of 2x minus 1. Well, we got log base 3, we can end up setting this and this equal to each other. So x squared minus 4 is equal to 2x minus 1. Push everything to one side, minus 2x plus 1 minus 2x plus 1. X squared minus 2x minus 3 is equal to 0. That means this can be factored as x minus 3, x plus 1. Which means x minus 3 equals 0, that's x is equal to 3. And then x plus 1 is equal to 0, that's x is equal to negative 1. So let's check, right? We have to check whether these work or not. So if I plug in 3 here, that works. Plug in 3 here, that still works. Plug in 3 here, that still works. Okay, so this one checks out. If I'm plugging in negative 1 here, well, negative 1 plus 2, that's a positive 1, that works. Negative 1 minus 2, well, that's a negative 3, that cannot work. So this is the one that's defined. This is the one that's undefined. Okay, so really your only answer here is x is equal to 3. Alright, 7b. So rather than, again, you can do this multiple ways, but rather than dealing with dividing here, I'm going to add this. So log base 2 of x minus 5, I'm going to add it to the other side. So I end up getting log base 2 of x minus 2 plus log base 2 of 8 minus x is equal to 3 plus log base 2 of x minus 5. I can end up adding these, multiplying these, because I can add. So log base 2, again I need a FOIL here. Okay, so x minus 2 times 8 minus x, that eventually will become log base 2 of negative x squared plus 10x minus 16. And then changing this 3 into log form, well, I can say this could be log base 3 times log base 2 of 2, which I can take up front here using power law. So 2 to the 3rd power is 8. So instead of saying 3 here, I can say log base 2 of 8. And then again, addition sign, that means I can multiply using logarithmic rules. 8 times 8x minus 5, that would turn out to be log base 2. 8 times x is 8x. 8 times negative 5 is negative 40. Alright, so log base 2, that's good. I can end up setting these equal to each other, so negative x squared plus 10x minus 16 is equal to 8x minus 40. Push everything to one side. I would like this to be positive. So I can push this to the other side, this one, and this one. Again, just to make that positive. So when I'm factoring, it'll become easier. So 0 is equal to x squared, and then negative 2x. That would be negative 24. Okay, so when I'm factoring this should be x minus 6 and x plus 4 is equal to 0. That means x is equal to 6 and x is equal to negative 4. What you'll end up finding out is this one will work and this one doesn't. Again, you need to check through each of your logarithmic terms. So check here, here, and here. If it works in all three, which 6 does, negative 4 does not work. For example, negative 4 will not work here because you get a negative number within your y place. Alright, 7c. For 7c, we have minus sign, again, same base, so we can end up doing division here. What you could do is I could add log base y minus 8, so we end up not having to do division just because it gets a bit messy, especially with these types of problems if we end up doing division. Okay? So that means I have log base 20y is equal to 2. Again, I'm going to change 2 into log form, so I can say log base 10, right? Plus log base 10 of y minus 8. I can use my power law, so bring that up in the back. So this would change to 100. 10 to the second power is 100. And then log base 10, I can end up multiplying these, where I have log base 20y is equal to log base 10 of 100y minus 800. Okay, so log base 10, I can set this and this equal to each other, so 20y is equal to 100y minus 800 minus 100y, negative 80y is equal to negative 800, which means y should be equal to 10.